Good morning, students. Can continuation of last topic, covalent bond. Okay, calculation of number of covalent bond. Okay, how many bonds, covalent bonds are present between the two atoms? Here we have the one simple principle. Then we'll calculate. We'll use the principle for the calculation of number of covalent bonds. Here number of covalent bonds calculated by using this principle, number of electrons shared by atoms by 2. Okay, number of electrons shared by atoms represented with S. Here, number of electron shared calculated by using this principle, n minus a, where n is equal to 8 into number of atoms, 8 into number of atoms, and here a is equal to number of valency electrons present in atoms. Okay. Next, here I am taking one example. Carbon dioxide. Okay, CO2 means carbon. Two oxygens are there, so we called dioxide. Carbon dioxide. C. Okay, carbon valency electrons. In carbon valency electrons 4. Why? Because it belongs to 14th group. Next, oxygen valency electrons 6. Why? Because it belongs to 16th group. It belongs to 16th group. And one more we need, number of atoms. Number of atoms is equal to 3 atoms. Okay. Next, you first calculate S. S is equal to n minus a. Before calculating the n minus a, n is equal to 8 into number of atoms 3. Okay, total 24. Next, A is equal to number of valence electrons present in atom. Okay, in carbon 4 valency electrons plus, okay, in oxygen 6 valency electrons. So how many oxygens are present here? 2 oxygens. 2 into 6. Okay, 6 into 2. Okay, 12. 12 plus 4, 16. Okay, here N is equal to 24. A is equal to 16. Then S is equal to 24 minus 16. S is equal to 8. Okay, then S is equal to number of electrons, number of covalent bonds. Number of covalent bonds is equal to S by 2. S is 8, here 2, okay, that means 4. Okay, here 4 covalent bonds are present in, okay, this carbon dioxide molecule. See, one structure of carbon dioxide. This is the structure of carbon dioxide. Here 2, here 2, 2 plus 2, here 2, here 2. Total 4 bonds are present. Okay, 4 bonds are present. Like this, okay, 4 bonds are present. This is about the just calculation of the number of covalent bonds. Next, in continuation, we will see now what is the meaning of covalency. Yesterday we discussed about covalency. Just I give different covalencies. Covalency is nothing but number of unpaired electrons present in outermost orbit. Okay, covalence. Covalency is nothing but number of electrons present, number of unpaired electrons present in balancing shell. We call as covalency. Suppose hydrogen covalency 1, okay, lithium covalency 1, beryllium 0, covalency 0, and here for example, okay, you take sulfur. Okay, here I am writing electronic configuration of sulfur, atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4, 3d0. Okay, here if 3d orbital is present, okay, it exhibits different covalencies. If rd orbital is not present, maximum exhibit, okay, 4 covalency. If d orbital is present in any atom, okay, it exhibits more than 1 covalencies. Suppose for example, here explaining sulfur with the more than 1 covalency. Okay, with the more than 1 covalency. See here, what is the electronic configuration of sulfur? 1s2, 2s2, 2p6, okay, 3s2, 3p4. Here 2 electrons. 1, 2, 3, 4. Here 3d 0. 3d 0. Okay, here this is the ground state electronic configuration. In ground state electronic configuration, sulfur has only 2 unpaired electrons. Only 2 unpaired electrons. So covalency 2 unpaired electrons. Okay, covalency is 2. Okay, in first excited state, see, first excited state means one of the electron excited from, okay, lower energy orbital to higher energy orbital. This electron jumped here to here. Okay, what happened? This electron jumped here to here. How many electrons are present? Total 4 unpaired electrons. 4 unpaired electrons. So covalency is 4. If one more electron jumped here to here, s orbital to d orbital. Okay, here we have now 6 lone electrons, 6 unpaired electrons. That is we call second excited state. In second excited state, it has 4 unpaired electrons, so 6 unpaired electrons. The covalency maximum is 6. Okay, maximum is 6. Like that also chlorine. Chlorine atomic number 17. Electronic configuration, right? I am writing electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5, 3d0. Okay, here I am writing first 3s, 2 electrons, 3p5, 1, 2, 3, 4, 5, 3d0. Here 0, sorry, 3d0. See, in ground state electronic configuration, chlorine has only 1 unpaired electron. So covalency is 1. When 1 electron jumped here to here, that means it forms 1 bond ClF, chlorine fluoride. Chlorine fluoride or IF, iodine fluoride. Okay, 1 more electron jumped, that means excited from 3p orbital to 3d orbital. This is we called first excited state electronic configuration. What is the first excited state electronic configuration? This one. Here we have the 3 lone electrons, unpaired electron. So covalency is 3. Example, IF3, iodine reacts with 3 chlorines. Next, if one more electron excited from 3p orbital to 3d orbital, okay, see how many are there? 1, 2, 3, 4, 5. This is we called second excited state electronic configuration. Here 5 unpaired electrons are present, so covalency is 5. See example for this molecule, IF5. Here also there. Okay, next you take one more. This if s orbital electron get excited from s orbital to, okay, here d orbital. Okay, that is we called third excited state electronic configuration. Third excited state electronic configuration. In third excited state electronic configuration, we have 7 unpaired electrons. 1, 2, 3, 4, 5, 6, 7. 7 unpaired electrons. IF7 is formed. Covalency also 7. This is about the covalency of different atoms in ground state and in excited states. See here, 2 unpaired electrons, that means Cl2 is formed. 4 unpaired electron, SCl4 is formed. 6 unpaired electron, SF6 is formed. All these in 2 covalency, 4 covalency, 6 covalency. This is the just importance of the covalency. Okay. Next in continuation, we will see one more important topic: types of covalent bonds. Next, types of covalent bonds. Okay, how covalent bond is formed? How covalent bond is formed? Okay, by sharing of electrons. By sharing of electrons. Okay, here both the atoms are having same electronegativity. The atoms which are involved in the covalent bond having same electronegativity, but sometimes, okay, the electronegativity difference is observed. Little bit electronegativity difference is observed. By that, okay, by that the bond moved toward the bonded electron moved toward the highly electronegative atom. Okay, such type of bonds we call as polar covalent bonds. And normally we called normal covalent bonded molecules we called which are having same electronegativity, that bonds we called as non-polar covalent bonds. So covalent bond may be of 2 types. Covalent bond may be of 2 types. One is polar covalent bond. Okay, second one, non-polar covalent bonds. Okay, first is a non-polar covalent bond. Example for this. Okay, here hydrogen, formation of the hydrogen molecule, formation of the fluorine molecule, formation of the chlorine molecule, formation of the bromine molecule. All these are the best examples for non-polar covalent bond. Hydrogen, okay, hydrogen equally shaded, so this should be non-polar. Chlorine and chlorine, this also non-polar. Fluorine, this also non-polar. Bromine, this also non-polar. Okay, all these are the homomolecules. Homomolecules could be simply considered as a homomolecule which are covalently bonded. Those are being simply considered as a non-polar covalent molecules, which are having non-polar covalent homomolecules. Okay, that bonds, particular bonds, we consider as a non-polar covalent bonds. Non-polar covalent bonds. And here, polar covalent bonds. Polar covalent bond means, for example, X atom is there. Okay, X1 atom is there. X1 little bit more electronegative than X. So bonded electrons also transfer towards X. Here it gets partially negative. Here it gets partially positive. There is no particular bond charges in non-polar covalent bonds, but in polar covalent bonds, just like this is also mini ionic bond. This is also mini ionic bond, not ionic but mini ionic bond. This is observed in two molecules. So many are there, but I will give two examples: water and hydrochloric acid. Okay, in water, hydrogen. In hydrochloric acid, hydrogen, chlorine. Okay, here hydrogen always partially positive. It exhibits partially positive charge. Why? Because here oxygen more electronegative than hydrogen. Oxygen more electronegative than hydrogen. So here we get partially negative. Okay, these are equally shared. Electrons equally shared by two atoms. But oxygen has more electronegative than hydrogen. So these bonded electrons always transfer towards oxygen, tends towards the oxygen. Hence, hydrogen gets partially positive. Delta indicates partially positive. This hydrogen also partially positive and oxygen partially negative. Here also see chlorine more electronegative than here. Oxygen more electronegativity. Oxygen more electronegative than hydrogen. Here also chlorine more electronegative than hydrogen. So chlorine gets partially negative and here hydrogen gets partially positive. This is about the one more simple concept: types of covalent bonds. Covalent bonds are two types: polar covalent bonds and non-polar covalent bonds. Homo molecules, homo covalently bonded molecules we called non-polar. These two different atoms are present. So hetero, covalently bonded atoms are best example for the polar covalent molecules or polar covalent bonded molecules. This is about the one more important topic: types of covalent bond or covalent molecules. Okay. Next, see the characteristics of covalent bond. Characteristics of covalent bond. Covalent bond characterized by using four important terms. Covalent bond characterized by four important terms. In those, the first one is bond length. Second one is bond enthalpy. Second one is bond enthalpy. Third one is bond angle. Third one is bond angle. First one is bond enthalpy. Here covalent bond characterized by using four important terms. Those are: first one bond length, second one bond enthalpy, third one bond order, Fourth one, bond angle. Covalent bond characterized by using these important four terms. What are those? One is bond length, second one is bond enthalpy, okay, third one is bond order, and fourth one is bond angle. Okay, see the definition of first one, bond length. Okay, the half of the distance between two covalently bonded atoms. This is two atoms nucleus. The half of the distance between two covalently bonded atom nucleus we call as bond length. Suppose it is a hydrogen nucleus, it is a hydrogen nucleus. These two are covalently bonded. Okay, hydrogen nucleus covalently bonded. Here half of the distance between, or we call average distance between two nucleus of covalently bonded atoms, we consider as a bond length. We consider as a bond length. Okay, here bond length. Okay, bond length directly proportional to the bond length indirectly proportional to the bond length indirectly proportional to the number of bonds. By increasing the number of bonds, bond length decreases. Bond length decreases. For example, see, carbon-carbon single bond is there. Carbon-carbon single bond length 1.54 angstroms. Carbon-carbon double bond. The single bond is present in alkanes. Double bond is present in alkanes. Alkanes 1.36 angstroms. Carbon-carbon triple bond molecules. Okay, here 1.20 angstroms. See here, by increasing the number of atoms, by increasing the number of bonds between two atoms, the bond length decreases. Bond length decreases. Okay, here bond length decreases. Why bond length decreases? By increasing the number of bonds, okay, the attraction forces between two atoms increases. So electronegativity between two atoms increases. By increasing the electronegativity between two atoms, the atoms comes to near. By increasing the number of bonds, okay, the atoms comes to near. Okay, like this, there is single bond present like this, double bond present like this, triple bond present like this. That means electronegativity increases. Due to increasing the electronegativity, the bonds will come near to each other. So bond length gradually decreases by increasing the number of bonds between the two carbon atoms. This is about the bond length. Next, bond enthalpy. Second one, bond enthalpy. Bonding energy or bond enthalpy. What is the meaning of bond enthalpy? Okay, the energy which is required for the breaking of bond, breaking of covalent bond, we call as bond enthalpy. Suppose carbon-carbon single bond, breaking of carbon-carbon single bond, we need nearly 360 kilocalories per mole energy. For breaking of silicon-silicon single bond energy, we require 180 kilocalories per mole. This is the energy required for the breaking of carbon-carbon single bond or silicon-silicon single bond. This energy we call as bond enthalpy. What is the bond enthalpy? The energy which is required for the breaking of covalent bond. Okay, breaking of covalent bond which is present between the two atoms, we call as bond enthalpy. Next, third one, bond order. Bond order. Okay, this can be explained by actually MOT, molecular orbital theory. We will see in continuation molecular orbital theory. The number of bonds present between the two atoms we called as bond order. The number of bonds present between two atoms we called as bond order. Hydrogen, hydrogen. Bond order is 1. Why? Because only one atom is present. So 1. Here only 1. Okay, and here oxygen, oxygen. In between two oxygen atoms, we have the two bonds. So bond order is 2. Nitrogen, nitrogen. 3 bonds are present. So bond order is 3. Okay, based on the bond order, we have to estimate the number of bonds present between the two atoms. Number of bonds present between the two atoms. This is we called as bond order. Next, we'll see in continuation one more important topic: bond angle. The angle which is present in present between the atoms which are covalently bonded, we called as bond angle. We are not expecting bond angle in ionic compound, not expecting bond angle in covalently bonded molecule. We expect only bond angle in, okay, here bond angle is related to only covalent bond. Okay, here M is there, here H is there, here H is there. Okay, these are all covalently bonded. These are all covalently bonded. Okay, the angle between three atoms or two atoms we consider as a bond angle. The angle between, okay, atoms which are covalently bonded we call as bond angle. Okay, here I am taking 3 molecules. Here I am taking 3 or 4 molecules. See here, H. It depends on electronegativity. Okay, 2 molecules are there. This is H2O molecule, water molecule. This is H2S molecule, hydrogen sulfide molecule. Oxygen is more electronegative than sulfur. So here bond angle is 104.5 degrees. Here bond angle is 92 degrees. Which has more electronegativity? That has that exhibit more bond angle. More bond angle. Especially bond angle depends on electronegativity of an atom. And here the bond angles and these shared pair electrons, these are bonded electrons. Here we have a lone pair of electrons. Okay. Bond angles mainly depends on bonded electrons and unpaired electrons. Bonded electrons and unpaired electron. Okay, based on this bonded electron and unpaired electron, we will explain bond angles by using one important theory, VSEPR theory. What is the VSEPR theory? Valence shell electron pair repulsion theory. By using valence shell electron pair repulsion theory, we will explain here bond angles, different bond geometries of coordinate molecules also, geometry of covalent molecules also will explain by using this one. This is about one of the important concept. Okay, in PU level or NEET level they will ask. In continuation we will see some more important concepts of covalent bond. Characteristics. These are characterized of covalent bond. Some more important specific characteristics of covalent bond. Covalent compounds are there and factors affecting on covalent bond is there. We'll see in continuation the topic. Thank you.